Hey there, this is N6.5%. This is probably one of the most important outcomes in math you might ever learn. So, N6.5 says you have to demonstrate an understanding of percent, and they're only talking about whole numbers, so just the numbers that we count with. Later on in life, you could find the percent of a decimal or a fraction, but for now, it's just whole numbers. So, concretely, like separating blocks into different percents, pictorially, so showing a picture, and symbolically, that means using numbers and symbols. So our first indicator says observe and describe examples of percents with whole numbers that are relevant to you. And so my best example would be, let me change my color here, on an exam. You might get a nice mark like 94%. So what does that actually mean? The next indicator says you will solve situational questions, provide justification, which means some proof for possible decisions using whole number percent to 100. So this is more about solving problems. So we'll get into that. Create and explain representations, concrete, visual, or both, that establish relationships between whole number percents to 100, fractions, and decimals. Now, these three words are super important: percents, fractions, and decimals. Did you know that they all mean the same thing? A percent can be expressed as a fraction could be expressed as a decimal could be expressed as a percent. They're all related. They're like cousins. They look a little different, but they all mean the same thing. Next one says write the percent modeled with a concrete or pictorial representation. So if I gave you a picture like this here, pie, and I had a piece of it shaded, I would ask you what percent, and you would say, oh, I know, 25%. Okay. Next one, explain why 100 is an important number when relating fractions, percents, and decimals. So there's a couple different reasons for this. The first one is that the word percent, look up at the top of the screen, per means out of. This is actually a French word, right? So if I said we're going to have one gift per customer, so one gift out of every customer, or one gift for every customer. Cent is a French number that means 100. So the word percent means out of 100. Okay? And we could write that as a fraction. So as a number, we don't know, maybe x over 100. So percent means out of 100. So that's why 100 is an important number for percents. It's also important for fractions because we could make an equivalent fraction if we have, look down at the bottom of the screen now, if you have something like 2 over 10, we could turn that into a number over 100. I just added a 0 on the bottom, so I'm going to add a 0 on the top. Well, if it's 20 out of 100, that means it's 20%, because anything over 100 can be expressed as a percent. And if I wanted to type 20 divided by 100, if you use a Dave, okay, your calculator would show, or if you wanted to work it out, that you end up with decimal 2. So they're all related. The last one, describe a situation in which 0% or 100% might be stated. So lots of different ways. If it's pouring rain right now, the weatherman would say there's 100% chance of rain, because it's definitely happening. It is for sure. If it's a 0% chance of rain, that means there's no humidity, there's no cloud in the sky, it would never happen. So 0% is never or nothing, and 100% is all or one. So remember that percents, fractions and decimals all mean the same thing. They all describe the same number, but they all describe, look up at the top, less than 1. They're all describing part of a number. Right? Part of a whole number, part of a pie, part of a pizza, or part of your paycheck. It's less than 1. So if you have a 0% chance, it's obviously way less than 1, but if you have a 100% chance, that means that that one thing is going to happen. If you got 100% on a test, you got the whole test right. If you got 94 in my previous example, that means you got parts of it wrong and parts of it right. Okay, let's move on to the next slide. All right, so we have a number line. Remember I said that percents, decimals, and fractions all show part of a whole. Well, this number line starts at 0 on the left side and goes to 1 over here on the right side. So all these numbers in between 0 and 1 are less than 1, right? They're on this side of the 1. So 0.9 is less than 1, and that means the same as 90%, which also means the same as 9 over 10, which also means the same as 90 over 100. All the same. So they've taken this number line and they've split it up into tenths. Okay? And you can see that at, let's say at this point, that's 1 of the tenths. So from here to here is 1/10, and 2/10, and 3/10, and so on, until you get to the end where you have all 10 tenths. Well, that means that you just have 1, because 10 tenths is the whole thing. 100%, or 1. Okay, so here's a little chart to show that the name, the model, the decimal, a fraction, and a percent can all show the same thing. So let's have a look at the first one. 1/4. And they want you to draw a picture of that. Well, I'm going to draw a box with 4 parts. Okay? Because the second word here, the 4th, down here we have tenths, down here we have hundredths. That tells me how many boxes I need to draw. And the first word shows me how many of those fourths are filled in. So in this case, we have 1/4. So remember, it's less than a whole, it's part of a whole, so part of this box, 1/4 of it is filled in. Okay. So I'm going to write over here that that's 1/4. And that's easy to draw from the name because it says 1/4, so we know it's 1 over 4. If I type this into my calculator and I did 1 getting divided by 4, does 4 fit into 1? Nope, it does not. So we start with a 0, and we have to use decimals now. Does 4 fit into 10? Sure does. 2 times. We subtract, we get 2. Does 4 fit into 2? Well, we have to bring down our 0. Does 4 fit into 20? Sure does. Exactly 5 times. So that's where they got 0.25 from. So if you typed this fraction into your calculator, it would say this decimal, 0.25. Now we know that this is the tenths place and this is the hundredths place. So we have 25 hundredths, right? And we could make an equivalent fraction to show that. All I did was multiplied the top and the bottom. I'm just going to change my pen color here. I multiplied the top and the bottom by 25, because what you do to the top, you must do to the bottom. And that's how I got 25 over 100. And I know that anything over 100 means percent. So if it's 25 over 100, that must be 25%. Okay, let's do the next one. They've given us decimal 8, and they've given us a fraction, 4/5. So because I just said the word 4/5, that's what goes in the name, 4/5. Okay, and we could draw a model. Okay, I have 5 pieces, and I'm going to color in 4 of them. Okay, so I have 4/5. I've drawn 5 pieces, crossed off 4 of them, got my fraction. My decimal has come from the fact that I used a Dave. So one of the problems, one of the misconceptions is, how do I put my fraction of 4/5 into a Dave? Well, remember this little rule. Your bottom, your big old bottom, sticks out. Sorry to insult you like that, but it just does. Okay, so the number that's on the bottom, which happens to be the 5, is the number that's going to stick out of the Dave. He's outside of the cave of division. The other guy goes inside the cave. Does that make sense? So remember that your bottom sticks out, and you're going to put that bottom number, that denominator, outside of the cave. So does 5 fit into 4? No, sure doesn't. It goes in 0 times, so we're going to have to use a decimal. Does 5 fit into 40? Sure does, exactly 8 times, and you're done. So 0.8 is how they got that decimal. Now, how do we find the percent? Well, if you look up at the top example of that 25, we don't even have to do the math. We just know that when there's 2 decimal places, those are your hundredths. So if we were to add the 0 to the 8 there, now we have 2 decimal places. What percent do you think 0.8 is showing, or 0.80? I hope you said 80%. Okay, let's move on to the next one. 7/10. So that's easy to draw as a fraction. 7/10. Done. Now let's look at the percent. It's saying that that's 70%. So we know that if there was a decimal and 2 spaces, we would have a 70 there. We can also tell from our fraction here that when we say the word 7/10, well, the 7 is in the tenths place. So we know that that's tenths right there. So we can just plunk our 7 down and we don't even need the 0. So it doesn't matter. We can put 0.7 or 0.70 or 0.7000000. We can go on forever. Don't let me make those look like 6s. All right, last one, 38 hundredths. Well, it's in the hundredths place, and there's 38 of them, so that makes an easy decimal. I'm not going to draw it. That would take too long, and I'm a terrible drawer. And as a percent, we know that those 2 decimal places are showing the percent. So it's just 38%. Plus, the fraction just gave it away. Anything over 100 can be expressed as a percent. Okay, so here's some real life examples. These are in the kitchen, chopping up a pizza. If you have 100 pieces of the pizza and this is 25 of them and that's 25 of them and 25 more and 25 more, you can say that there's 25% of the pizza. Nobody would cut their pizza into 100 pieces, so probably a bad example. A better example is when you read a label, you're going to see percentages all over the place. So this peanut butter is saying that 1 serving of peanut butter is going to give you 20% of your daily sodium intake. So let's imagine that I'm going to change my color here, that you have a little measuring tube, and every day you fill this tube with sodium, delicious, and that is what you're allowed to eat for your salt content for the day. Well, it's saying that if you eat this here peanut butter, you've consumed 20% of your sodium. So imagine that this tube shows 100% of your sodium intake. If we split it up 20, 40, 60, 80, 100, okay? So by eating the peanut butter, that means that you've used up 20% of your sodium intake. Some other real life examples of how we use percent. Taxes. So you can see on the Walmart bill in this, I'm not sure where this bill, oh, Ontario. See right there? Tells you. If this bill was in Saskatchewan, you would see that the PST is 5% as well, because Saskatchewan has 5% GST and 5% PST. So anyways, if you're buying something large like an LCD TV, that is what they purchased, it was $798, and then they bought a worm. I don't know why you'd buy a $3 worm, but they did. Anyways, their subtotal was around $800, $801 right there. Then the tax, $40.05 for GST and $64.08 for PST. So they're paying over $100 in tax. Seems like a lot, doesn't it? So you might get a good deal on the TV. It was only $800, but then you had to pay $900 before you left the store, because $100 of that was tax. So it's really important to know how to do PST and GST, how to do percent, because you're going to need that when you go shopping. So that's what I've said here with the little red note. Saskatchewan charges 5% for both. So that makes for easy math, because you can calculate 10% in your head. It's awesome. So you might see, for example, a sale that says 10% off. You're going to need to know how to calculate that percent. You might see it in charts and statistics, such as this food or this pie graph that is showing what you spent for this month. Well, it's saying you spent 30% of your bill, 30% of your wage, or all of your expenses went to lodging. 25% went to food. 14% went to entertainment, 19% to transportation, and 12% to miscellaneous. So because we know that percent means something, remember that French word that we just learned about, what do you suppose all those numbers add up to? I hope you said 100. So that's the cool thing about a circle graph. It has to add up to 100, because a circle graph always shows parts of a whole. Down here with the youth e-cigarette use increased nearly 1,000%. So you can have percents that are actually bigger than 100. And you'll see that in statistics from time to time, and it's kind of confusing, but it didn't just increase by one whole of itself. It's increasing almost 10 times, because 100% just means one whole thing, but we have this extra zero, so it actually increased by 10 times as much. And you can see that in 2011, down here at the bottom, 1.5% of kids were using e-cigarettes in the past 30 days. That's what the little fine print here says. So in 2011, 1.5%. By 2015, it had gone up to 16%. So a difference from 1.5% of kids using an e-cigarette to 16% of kids using an e-cigarette. That doesn't sound like a big difference. It only went from 1.5 to 16. But when you hear it or see it in the news, look at how awful this looks. 1,000%. Wow, wow, wow. That's huge. And they've made their chart to make it look huge. But let's look at the side numbers over here. This chart doesn't go from 1 to 100. This chart only goes from 1 to 15 or 16. And so This looks like it's the whole thing, but it's really not. It's only 16%. If they would have made the chart from 1 to 100, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and they have 2011 here and 2016. Well, 2011 is, let me just change the color here, is down here somewhere, and then 2016 is about here somewhere at 16. It wouldn't be very impressive, would it? So you'll often see that ads and statistics like this are trying to really make a statement by kind of manipulating the data. So it's important that you know how to use percents so that you aren't tricked into believing it. Now, on that note, e-cigarettes are bad. Don't use them. All right. A couple more examples. We've already talked about getting an exam score. If your teacher hands you back a paper that says 7 out of 10, you should be able to calculate in your head that that is 70%. Okay? And to do that, you would just type on the calculator 7, and then you'd hit the divide sign, 10, because a fraction bar actually means divide. Okay? So 7 divided by 10, it would give you 0.7, and then you'd say, oh, the first 2 digits are the percent, so I'd have to fill that in with a 0. I got 70%. So you should be able to eyeball your percentage if it's out of 10 and know what percent you got. Now, what if it's out of, I'll just change colors here, what if you get 4 out of 6? Well, I don't know what the percent of that is. So you could type that into your calculator. I'm just going to do that with you. Okay, so you would hit 4, divide by 6, hit the equal sign, and it would show you 0.66666 repeated. So take the first 2 digits, 66, but you could round up because the next number is a 6 and that's big enough to round it up. So that wouldn't be 66%, it would go up to 67%. Okay. The last examples over here are just drawings. There are 100 squares in that chart, and they've highlighted or they've colored in blue 50 of them. So 50 out of 100 or per, right? Because percent means out of 100. So if you have 50 out of 100, that means 50%. In this case, 25 of them are colored, so 25%, and the last one, 75%. Lots of different ways you can show percent. All right, good luck.